Module 5, Lesson 1 deals with roots. The content objective is students will find square roots and cube roots, and suggested pacing says this is a 90-minute lesson, and I wouldn't have thought so, but you know they've got 25 resources in this one, so it probably is going to take a little while. The square base of the Great Pyramid in Giza covers almost 562,500 square feet. The equation x squared is equal to 562,500 can be used to find the length x of each side of the square base. Okay. The equation, yep, I already said that. How do you think you could solve this type of equation? Well, that is the kind of thing that you're going to be learning about in today's lesson. Our inquiry question says, what does the square root of a number mean? Well, let's dig into that a little bit and see what we can find out. Virtual dot paper can be used to measure the side lengths and area. Each group of 4 dots is a square with a length of 1 unit, a width of 1 unit, and an area of 1 square unit. Drag the point to change the size of the square and use a virtual dot paper to examine the measurements of the side length and area of the different size squares you create. Record your observations of 3 different size squares. So you can see right here they've got the 1 square, which that'll be one of our squares we record, which is a side length of 1 and an area of 1, because 1 times 1 is equal to 1. And of course we know that the area of a square is the same as a rectangle. Area equals base times height. Therefore we can say that the area is going to equal to 1. And they're referring to the base and height as length as width, but that's okay too. If we were to take and make our square a little bit bigger, we could take and do, let's say, 3 by 3. Then you have 1, 2, 3 for your height, 1, 2, 3 for your length. 3 times 3, that's going to give you an area of 9. That'd be the next thing you'd be writing down. And then let's go ahead and do a 5. So you have a side length of 5 times 5, which will give you an area of 25 squares contained inside of it. Now we're going to take and do the same thing, only we're going to be recording our values on this chart that they gave us. So first off, an area of 1. Let's go ahead and move this up where we got some room to work. An area of 1 has a side length of 1, so we're going to type a 1 in right there. And then if it has a side length of 2, that means right there it tells us the area is going to equal to 4. If we have an area of 9 would be the next one, the side length is going to be 3. If we have an area of 16 to be the next one, that's going to give us a side length of 4. And we need to move our square down a little bit here. If we have an area of 25, that means our side length is 5. And if we have a side length of 6, that means that our area, that's going to end up being 36. And give a little more working space. Area of 49, that gives us a side length of 7. And what do you think the side length of an area of 64 is going to be? Yep, you're right, it's going to be 8. Check your answers, and all of our answers check. Now if you notice, there's a pattern going on here where if we take and multiply the side length times itself, we get the area. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. When you multiply a number times itself, it's referred to as squaring it. Because if you think about what we're doing here, we're taking and making a square, and when you multiply the number times itself, you're squaring it, creating a square, and the solution to that square is going to be the area of the thing you're creating. If we were to go backwards, instead of trying to find the area, they gave us the area, and we wanted to know what the square root is. Well, the square root's what number times itself is equal to that number, which we're doing with 25 right now. The square root of 25, that's 5, which just so happened to be the side length. If I was to do something different, say the square root of 64, that's going to be 8, which just so happens to be the side length. Let's try a different one. Let's go a little bitty one here. Area is 1. The square root of 1 is 1. which just so happens to be the side length. So the inverse of the square would be to find the square root, the two numbers that multiply together times themselves in order to get to that next number, or the square. Now with those skills, how about you pause the video for just a minute and answer the questions on here. Oh, the square root of 81 is 9, because 9 times 9 is 81. 100 is 10. 10 times 10 is 100. 11 times 11, that's 121. 12 times 12, that's 144. 13 times 13 is 169. 14 times 14, I really didn't know that one off the top of my head, but that's going to be 196. And 15 times 15, that's going to give us 225. I think that's enough inquiry for right now. It's time that we get in here and actually start learning some stuff. So the first thing we want to learn about is the square root, and the definition is going to be down there in the flip card, but we're going to go ahead and highlight the word. The definition of square root is the square root of a number is one of its two equal factors, meaning one of the two numbers that multiplies by itself to equal that number. In symbols, we're going to indicate it by saying that if x squared is equal to y, then x is going to be the square root of y. It gets kind of confusing when you're looking at it that way. But if we had it with numbers, we could say that 5 squared is equal to 25. Therefore, 5 is going to be the square root of 25. 5 is a number that when it's multiplied by itself, it equals 25. That's what makes it a square root. And then we have a perfect square, which is a rational number whose square root is a whole number. Now the perfect squares are what we really like to use, because these are the numbers that we can do easily in our head within reason for what the numbers would be. And it's really important that you start working on memorizing these perfect squares. So the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, 16 is 4, 25 is 5, 36 is 6, 49 is 7, and 64 is 8, making each of these numbers in the bottom the square root. And these are also perfect squares because every one of them is a whole number. So if the square root is a whole number, it becomes a perfect square. Now something else to consider is that every positive number has both a positive and a negative square root. Let's take 9 for example. 3 times 3 is equal to 9, right? So 3 is going to be the square root of 9. But doesn't negative 3 times negative 3 also equal 9? Yes, it does. And that means that negative 3 is also going to be a square root of 9. So 9 has two square roots, 3 and negative 3. Now we generally take and use only the positive square root, also known as the principal square root. And that's going to be a vocab term. And the negative square roots, you deal with those later on in math. You're not really dealing with those much in our class today. A radical sign, that's that funky little shape right there, is used to indicate a square root. And for example, here you can see that the square root of 25 is 5. The negative square root of 25, that's going to become negative 5. Notice that negative sign is outside the radical house, so you put it on after you find the square root. And then you have this other cool little thing, which you've probably never seen before. That's a plus minus, or a positive negative. So right here we're going to say the positive and negative square root of 25 is going to be plus and minus 5. So that means that's a way of indicating that we don't know if they want the principal square root or the other one, so we're going to go ahead and list them both, the positive 5 and the negative 5, for an answer. Now the textbook here wants us to find the positive square root of 64. The way we know it's looking for a positive square root is it doesn't have the plus minus sign out on the side of it. There's no minus sign outside of it, so we know it's going to be a positive square root. So we're going to ask ourselves what number times itself is going to equal to 64. Of course, that number is going to be 8. Your factors of 64, well, we got 1 times 64, 2 times 16? No, that's not 64. How about 4 times 16? Yep, that'll work. And then 8 times 8. But would this one work? 1 times 64, 2 times 32, 4 times 16, and 8 times 8. That one's going to be all your factors of 64, all the things that would multiply to get to equal it. And then, of course, the 8 is the one that multiplies by itself, so the square root of 64 is going to be 8. So let's start taking and looking at some problems here. We have 289, and it wants to find out what is the square root of 289. And 289 is not a common number, so we're going to take, and since it's not one of the more common ones, I'm going to teach you how to do this using a calculator. Now, I'm not always going to allow you to use a calculator on square roots. Most perfect squares, I would expect you to be able to figure it out without one. But here we're going to take 289, and we're going to hit the radical button, which you can see right here. That has a little 2 with the radical with an x inside. That would be a square root, and you can see that that is 17. Now, most perfect squares, I would expect you to be able to figure out on your own, but something like 17, that's kind of an oddball one, and that's going to take a little bit more work to figure out. Now our textbook is just getting downright mean. It wants to have both the principal square root and the other one, the negative square root, of a decimal number. Well, if the decimal wasn't there and we were just looking at 121, what number times itself would equal 121? That would be 11. So we know that 11 is going to have something to do with it, and the only question we really have is where's the decimal going to end up getting placed in our problem. So let's go ahead and take a look at how they chose to work it. They said, step 1, since there's an even number of decimal spaces, consider the square root of 121 and determine what multiplied by itself is 121. And that, of course, is going to be 11, just like we already said. And from there, we need to say, okay, well, where's the decimal going to fall? We know 11 is going to be part of our answer. The decimal place in our problem, 1.21, that was 2 decimal spaces. So we need to say, okay, there's only 2 options for placing decimal point on the 11. Are we going to take it before both digits or between both digits? I'm going to say it's going to be between both digits because, let's take a minute and just look at this on a piece of whiteboard here. If I was to take and multiply 1.1 and 1.1, 1 times 1 is 1, 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 1, 2, 1, and then look, bounce, bounce, that's 2 bounces, bounce, bounce, so my decimal would end up there. But I knew I was going to have to bounce it twice to get to that 1.21, so that meant that the decimal had to be just 1 space in on both parts of the problem. So with that in mind, we're going to multiply 0.11 and 0.11. That would end up having 4 spaces because you go bounce, 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 bounce. That's not going to be the number we want. If we wanted to multiply, if you multiply, then the product will have to have 2 decimal spaces, I think is what they're looking for here. So we're getting from there, that means we're going to have 1.1. Check our answers. All of our answers are going to be correct. Alright, you take a minute, pause the video, work this problem on your own. Did you get it done? I hope so. Here we're looking at the plus or minus square root of 0.81. So we need to say, well, first off, if it was just the square root of 81, the square root of 81, that's going to equal to 9. But I've got, in my problem, I've got 2 decimal spaces in, so that means that I have to multiply something, or 2 things that are 1 decimal space in each in order to get to the answer. So that means we can actually multiply by 0.9, because the 9 times 9 would be 81, and when you bounce that decimal 2 times, as you see here, 0.9, 0.9, that's going to give me my 81, bounce, 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 bounce. That's where the 0.81 comes from. But you got to remember this part as well. You've got to do the plus or minus 0.9, and that is going to be your final answer that we're going to put in for our check here. And you can see they've already got the plus or minus for us there. 0.9 is what's going to go in here. Check the answer, and the answer checks. That is going to be it for part 1 of this lesson. Come back for part 2 as we continue our study of roots.